Okay, guys, we're going to try and put all the things that we have learned over the last couple lessons together and see if we can graph some of these functions. So I still want to start off by identifying the holes, horizontal asymptotes, domain, and again, ignore this limit behavior business. We're just going to look for vertical asymptotes. And I know it's not listed here, but I also want to check for slant asymptotes also, because that's going to make, if I know where they are, it'll help me make my graph a lot easier. Okay, so let's go ahead and zoom in, and there we go. And we're going to start off by factoring. Okay, so let's factor this numerator. I can turn that into, take out a -2, x squared, and I would be left with x plus 1, right? Okay, so there's my numerator factored, and then my denominator, I'm able to take out an x, and then I'd have x squared plus 2x minus 3. So if I factor that completely, it's going to be x times x plus 3 times x minus 1. Okay, so I don't need this anymore. Okay, so now I have everything factored, and I'm ready to talk about my domain. So my domain is going to be all reals except for anything that makes my denominator turn into a 0. And in this case, I'm going to have 3 things. I cannot have 0, I cannot have -3, and I cannot have +1. Those 3 numbers would create a 0 in my denominator, which I can't have. So my domain needs to exclude those values, okay? The next thing I want to do is see if anything cancels from my numerator and my denominator. And there is one thing that cancels, and it's right here. This x can cancel with the x squared. So remember, x squared is really x times x. So I can cancel one of those x's out with the x in the denominator. So that means that this x is going to go away, and this x squared is going to turn into just an x to the first. So I'm actually gonna write it like that. Like that. Oh. I keep making it worse. Okay, there. And that's the only thing that cancels. And in fact, what I recommend doing right now is I'm going to write what my factored function looks like after everything's canceled out, kind of clean it up a little bit. So it'd be -2x times x plus 1. And then in the denominator, I have x plus 3, x minus 1. Okay, so that's just going to help me later because I'm going to have to plug in some values, and it's just nice to have a nice clean version to look at. Okay, so I've got my domain. The next thing I want to find out are if I have any holes in this graph, and I do because I canceled something out. If you cancel something out, you're going to have a hole there, okay? So I'm going to have a hole at 0 because if I canceled out an x, that means that the 0 that belongs to that is 0, right? So remember, if I had canceled out x plus 3 over x plus 3, right, there would have been a hole at -3. Oh, my son's being a dragon today, so hopefully he stays out of earshot, but you never know. Okay, so anyway, right, so I cancel out the x's, so I am going to have a hole at 0. Hole at x equals 0. Okay, and then I want to talk about vertical asymptotes. You're going to have vertical asymptotes when you look at your factored version, whatever makes the denominator turn into 0. So I'm going to have 2 of them in this case. I'm going to have a vertical asymptote at x equals -3 and also at x equals +1. All right, and then I look at the horizontal asymptotes. So that, remember, you go back to your original and you look at your degrees. So since the degrees are equal for the numerator and denominator, they're both 3. That means that the horizontal asymptote is at the line y equals whatever the leading coefficient divided by the leading coefficient is. So in this case, the leading coefficient of my numerator is -2. And the denominator, it's just 1. So -2 divided by 1 is just -2. Okay, so now I have all these important pieces. I'm going to go ahead and put my asymptotes on the graph, and then we'll go from there. Okay, so let's see. I have a vertical asymptote at x equals -3. I'm going to do these as best I can. And then another one at +1. And I also have a horizontal one at -2. All right, so there's my asymptotes. Now, here's something that's super important that we need to talk about. Vertical asymptotes can never be crossed, ever, by your curve. So let me switch to blue. Okay, so basically something's going to happen over here because I can't cross that vertical asymptote. Something's going to happen in the middle, and something's going to happen over here. There's really kind of these 3 parts that I need to look at. Now, a horizontal asymptote as well as a slant asymptote, you can actually cross over. So what's the point of them? Why do we even have them? Well, they are going to tell you what your end behavior is going to do. So the very ends of this graph, I know, are going to ride along the y equals -2 horizontal asymptote. It doesn't necessarily tell me what's going to happen in the middle, right? So I don't really know that part. But vertical asymptotes are absolute. I cannot cross them. Absolutely not. So I like to start in the middle. And a few things that we can do to kind of give ourselves some more information. I do know that I have this hole at 0, but it might be helpful for me to kind of find some of my intercepts, maybe my X-Intercepts. Let's see if that's helpful at all. So the easiest way to find your X-Intercepts is to go to your factored version, right? So this one that I have here in red, and I'm going to look at the numerator. Whatever makes the numerator turn into 0, that's going to be my X-Intercepts, right? So in this case, if x were 0, it would make it would turn that what do you call it, that numerator into 0. Now don't forget I have a hole there, so if I plug in 0 for x, I get out 0 for y, but that's actually not part of my graph. There's a hole there, so I'm going to graph that by putting an open circle over 0, 0. Okay, now you'll also notice that -1 would turn my numerator into 0. So that's not a hole though, because I only had a hole at x equals 0. So it's not a hole, it's just that when I plug in -1 into the graph, I'm going to get out a 0. So it's just another point. So I'm going to put a closed dot right there. Okay, so now here's, yeah, and I don't have any other X-Intercepts. That's it. So how do I find the rest of this graph? How do I know what's going on? So it might be helpful if you have a calculator near you, because basically what is going to happen is I need to know what's happening in between my vertical asymptotes, okay? So from the hole that I graphed, that at 0, 0, my graph could do 2 things. It could shoot up and go this way, or it could shoot down and go this way. It's going to go one way or the other, right? Because it has no other option. It either has to go up or it has to go down. I just have to figure out which of the 2 it is, okay? And then the same thing is going to happen. I know that these 2 are 0, so not much is going to happen in between there. But then from here, either it's going to shoot up like this, or it's going to shoot down like this. I don't know which it's going to do. I'm going to have to figure that out. Okay, so how do you find those? You really just are going to plug in some values. Okay, so that's why it's going to be helpful if you have a calculator, because unfortunately for this one, if I'm trying to figure out this side, if it's going up or down, look where I'm at. I'm in between 0 and 1, so I have to plug in a fraction. Oh, there's my son. Anyway, so let's see how far we can get in this video. This is already try number 2, so Anyway, so I'm going to plug in a positive 1/2. And I'm going to also recommend that you plug it into your factored version. It just makes your life a little bit easier. So let's just go ahead and pop in a positive 1/2 and see what comes out. So -2 times 1/2 times 1/2 plus 1 would just be 1.5. And I'm going to divide that whole thing by 1/2 plus 3 would be 3.5 times 1/2 minus 1 would be a -1/2. So that's going to spit out a positive 0.857 blah, 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 blah. I don't really care about the number. In this case, I really just care about the sign. Since it's positive, that means that this is just going to go up like that. All right, great. Now I'm going to go ahead and plug in -2 makes the most sense to figure out, is this going this way or is it going to go this way? I don't know. So let's just plug in -2 real quick. So, and again, I'm going to plug into that factored version. So -2, let's see, that would be a positive 4, -1, divided by, what am I plugging again? -2, so that's a 1 times a -3. Okay, and I get a positive 1.3, blah, 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 blah. So that means that this is going to go off that way. Okay, so now we have this middle section of the graph. Now all I have to do is figure out what's going on over here and what's going on over here. Okay, and then I'm pretty much done. So again, I'm just going to have to pick some values. So why don't I go ahead and just plug in, I don't know, let's plug in +2 and see what comes out. Right, so just take a minute and do that. Okay, let's see. I get out a -2.4. So when I plugged in +2, I got out -2.4. So that means I'm kind of down here. Now, one thing I do know is, remember, I don't have any other X-intercepts, right? The only ones I had were at 0 and at -1. So I know that this isn't going to go this way because it doesn't cross the x-axis again. Okay, if you weren't sure, you could go ahead and plug in like 1.5 and see what happens. But I know that it's not going to cross the x-axis again. So that means that this must go this way. Oh, God. Let me try that again. There we go. This one's got to go down that way. All right. And now I know this end is going to ride along. So I know that that's pretty much how that side's going to go. Okay, now I just need to figure out over here what's happening. So let's try that.
Mommy.
What, honey?
Where's it coming?
I'll be there in just a minute. Okay, so now let's go ahead and plug in a number like -4. So just take a minute and plug in -4 here, and let's see what we get out. Okay, and then we're going to, sorry, keep losing my place. -1, -5. Okay, so I get a -4.8 when I plugged in a -4. So this one's down here. Okay, so again, I know I'm not crossing that x-axis, so I know this one's gonna do basically that. Okay, because I'm never crossing the x-axis again, and I know that this, in the end, is just gonna get super close to that line. So it may jump over it a little bit here, it may stay underneath, but I know it's just gonna keep going towards that y equals -2 line. Okay, so when I'm looking at your graphs, I'm looking for a couple of things. Most important are your asymptotes. Are they in the right spots? Okay, so get your asymptotes set up. And then I'm just gonna see, like, did you put a hole in the right spot? And then I basically just wanna see that you have the shapes correct. So for example, this branch that we just drew, right? If you had it up here, obviously that's incorrect. You didn't plug something in. You'd have to be able to figure out where that goes, right? But if you knew, okay, if you plugged in enough to know that it's down here, that's really all I need to see. So asymptotes, and then just that the pieces of the graph kind of resemble the shape that they're supposed to. All right, so let's see if we can try the second one now. All right, so we're going to start off the same way. So we always start by factoring. So let's see, this numerator is going to turn into x minus 2, x minus 4. And then in my denominator, let's see, we could factor out a negative 2 to begin with. So that'd be a plus x minus 6. So that's going to factor into negative 2 times x plus 3, x minus 2. Okay, there we go. So there it is factored. So now I'm ready to talk about domain. So that's going to be all reals except in this case, a negative 3 and a positive 2. Okay, because those are the two things that make my denominator turn into 0. All right. Oh, I didn't mean to be erasing that. Then we're going to go ahead and see if anything cancels out. And I do have something that cancels this time, the x minus 2's. Those cancel. So that means I'm going to have a whole at x equals 2. All right, then vertical and horizontal asymptotes. So let's talk vertical asymptotes. Now that we're looking, I'm gonna draw it down here. Here's my factored version. We'll write it nice and neat so it's easy to look at. X minus 4 over negative 2 times x plus 3. Okay, so I look at my factored version and I see, is there anything that would give me a 0 in the denominator now? Yes, negative 3. So I'm going to have a vertical asymptote at x equals negative 3. And then horizontal asymptote, that's where I have to look at the degrees. So I look at the degree, they're equal in this case. So that means the horizontal asymptote is going to be the line y equals whatever the leading coefficient divided by the leading coefficient is. So looks like negative 1/2 this time, negative 1/2. Okay, that might be a little tricky to graph with my inadequate tools, but we're gonna do the best that we can, all right? So we have all of our asymptotes laid out. We know where we're gonna have a hole. Let's go ahead and sketch some of this. So vertical asymptote, only one of them this time at negative 3. Okay, there we go. Now we have a horizontal asymptote at y equals negative 1/2. So, about there. Okay, that's the best I can get it. So let's see. What else would be convenient for us to find? Let's go ahead and find the X-Intercept. So to remember to do that, we're going to look at our factored version and we're going to look at the numerator. Whatever would make that numerator turn into a 0 is going to be in X-Intercept. So in this case, it would be a positive 4. So let's change my color. So I know this thing is crossing the x-axis at positive 4. So I'll put a nice dot there. I also know I have a hole at x equals positive 2. So what I'm going to do is I'm going to take, I know it's at positive 2, but positive 2 comma what? I have no idea. So to find that, I'm going to take positive 2 and I'm going to plug it into my factored version and see what comes out. So let's see. Just grab my calculator. That would be a negative 2 divided by, let's see, we'd have negative 2, and then what am I plugging in again? Positive 2. So that would be times 5. So I get 0.2. All right. So at 2, comma 0.2, I have a hole in my graph. So, oh geez. This is difficult to draw. Just keeps getting worse. Okay, that's as good as it's gonna get. All right, so here's a couple of things that I know. Oh, and you know what? It probably will be helpful to find a y-intercept. So let's go ahead and plug in 0 for x real quick and just see what our y-intercept is. So in fact, I'm actually going to go back to the original because that would just get me 8/12, right? So that's 2/3. Okay, so at 0, 2/3. Oh, trying to make it at 2/3. It's not really going well. All right, so now I have a bunch of information about this. And since I already have my asymptotes laid out, I kind of know what's going on here. This is going to ride along the asymptote here. It's going to go until it hits the hole right there. So remember, that little open circle is a hole. My graph does not exist there. And then this is just going to continue on and shoot up like that. Now, how did I know it was going to go up and not down? For a couple of reasons. Because look at these 3 points. They were getting higher and higher and higher. So the graph isn't, you know, it would be unusual for it to kind of go up and then all of a sudden shoot down. It's possible, but I don't think that's really going to happen. But I also knew that 4 was my only x-intercept. So it can't come back down. That wouldn't make any sense. So I have my asymptotes there. I know that one's just going to shoot off to positive infinity. So now all I have to do is figure out what's going on this side, and then I'm pretty much done, right? So you really just look at your vertical asymptotes and then figure out what's going on each part of it. Okay, so let's go ahead and, oh, I don't know, maybe we'll plug in -4 and see what's happening. So I'll just grab my calculator again, plug in a -4 into my factored version. And that's going to get out for me a -4. So -4, -4, which means that I can reasonably conclude, since my vertical asymptote, remember, I can never cross over them, and I don't have any more x-intercepts. So this is just going to do this. That's it. Okay, hopefully this one wasn't as bad as the last one was pretty tough, but this one had a couple less pieces, so hopefully that's all right. Okay, let's try one more together. Okay, so start off by factoring. The numerator becomes x plus 3, x minus 3. And that denominator, I can take out a 2, and I'm left with x plus 1. Okay, so let's talk domain. All reals except -1. Holes. Does anything cancel out? No, not this time. So that means this one has no holes. So asymptotes. Oh, vertical asymptotes, sorry. Vertical asymptotes, let's see. So my factored version, what would make my denominator turn into a 0? The only thing is a -1. So I have at x equals -1 is going to be a vertical asymptote there. And then for horizontal asymptotes, let's go ahead and look at our degrees. So in this case, the numerator is greater than the denominator's degree. So there is no horizontal asymptote, but there might be a slant asymptote. So now I have to ask myself, okay, well, is the degree of the numerator 1 more than the degree of the denominator? Because remember, it has to be exactly 1 more. It is. Okay, so in order to find that slant asymptote, now I'm going to have to do long division. Okay, so let's see if I can squeeze this in here and we can figure out where our, so actually I have none for the horizontal, but I am going to have a slant asymptote. Okay, so let's see where it is. So I need to do 2x plus 2, and I'm going to divide that into x squared plus 0x minus 9. Make sure you have the 0 placeholder. Okay, so 2x times what gets me x squared? I'm going to have to deal with fractions this time. Oh, well, so that would just be a half x, right? And let's multiply a half x out. You'd get x squared plus x. But now I need to come in and subtract. So that's going to be a minus. That's going to be a minus. X squareds cancel. 0x minus x is going to get me negative x. Drop down the negative 9. And then I do the same thing. What do I multiply 2x by to get negative x? So in this case, that would be a negative 1/2. Oh, the negative kind of blended. Hold on. Let me do that again. Negative 1/2. There we go. So multiply that through. Negative 1/2 times 2x is going to be negative x. Negative 1/2 times 2 is negative 1, but then I come in and subtract them both, so they turn into pluses. That's gone. I get a negative 8. There's nothing left for me to bring down, so I actually don't even care about the remainder. There's my slant asymptote right there. This, y equals that thing right there, right? So my slant asymptote is y equals 1/2 x minus 1/2, which is just a straight line, right? It's an inconvenient straight line because the y-intercept is a negative 1/2, but that's fine. Okay, so let's kind of sketch out what this is going to look like. I have all of my asymptotes laid out. Let's switch to red. Okay, let's see. I'm going to have a vertical asymptote at negative 1. I don't have any horizontal asymptotes, but then I have a slant asymptote at the line y equals 1/2 x minus 1/2. So I'm going to start at negative 1/2. I'm going to do this as best I can. And then we're going to go up 1 over 2. Up 1 over 2. Up 1 over 2. Okay, so my slant asymptote is going to look like, oh my gosh, this is so bad. Hold on, I'll do it again better. That's better-ish. Okay, there we go. All right, so again, something's gonna happen over here, something's gonna happen over here. I just have to figure out what.
Come here. Come here.
Buddy, you gotta wait a minute.
Come here.
Maybe Daddy can come help you.
Okay. Daddy. Daddy.
Okay, so let's now go ahead and plug in. We never found our Y-intercept, did we? Okay, let's do that right now. So if I plug in 0 for x real quick, that's going to get me a negative 9/2, so negative 4.5. Okay, so that tells me, oh, and let's go ahead and find our X-intercepts too. So I'd have them at positive 3 and at negative 3. So positive 3 and another one at negative 3. Okay, so that's going to help me out when I go to sketch these. And it actually helps me a lot because remember, my asymptotes, look, it's just going to come and go right like that. And then on my other side, it's going to do kind of the same thing. It's going to hug this one, hit right there, and then go off that way. Okay, and that's pretty much it. So once you get all the bones set up, all your asymptotes, find the couple of other additional pieces that you need, like the X-intercepts and Y-intercepts, and then it should all kind of fall into place and hopefully work out. If you don't have a graphing calculator, feel free to play around with Desmos. And I know I give you the answers at the end of this, but if you wanted to use that as a calculator, you can do that too. All right, hope this helps. I know this stuff is kind of tricky, so we're going to practice more of this tomorrow, but feel free to let me know if you have any questions.